Welcome back. This is section 6.6, which is 5.6 in your textbook, on free fall explained. So when we've talked about free fall, we know that you're going to get faster and faster as you move towards the center of the earth, and the reason is because gravity is pulling on every mass, and the earth's mass is bigger than, say, your mass, and so the earth is pulling on you, and that will cause you to accelerate. Here's a question that you may not have thought about. If two people fall out of an airplane at the same time and one of them is much bigger than the other, since the second one has more mass, will the earth pull on him more than the earth pulls on the little guy? What do you think? Gravity is based on mass. The more massive you are, the more gravity there is. So yes, there would be more of a pull of gravity on the big guy than on the small guy. So the question is, why doesn't the big guy fall faster than the little guy? Galileo was an Italian guy during the Renaissance, one of the first to do serious physics experiments, and he dropped 2 cannonballs off the top of the Leaning Tower of Pisa. It was leaning, I guess, even then. And Aristotle from antiquity said that the larger one should fall faster than the small one. And no one ever thought to test it. Well, Galileo, he decided to actually test these things. And he used cannonballs, which are, spherical and would displace the air pretty well, and found that there is no difference, that they hit the ground at the same time. He recognized later that if there was no air, that it would absolutely be the same time, that the masses, even though the Earth's pulling different on them, would hit the ground at the same time. It was actually done on the first lunar landing. I believe Neil Armstrong dropped a feather and a hammer, and they hit the lunar surface at the same time because there's no air on the moon. So he dropped a 10-kilogram cannonball and a 1-kilogram cannonball, and they hit the ground at enough of the same time that people realized that the larger one should have been faster, but it wasn't. So the idea, or the question that remains, is why wasn't it? If mass has to do with, or gravity has to do with mass, why didn't the big one fall faster? So if you were to have 10 times the mass, you'll have 10 times the gravity. So if you were to have Newton's law of force equals mass times acceleration, and you have 10 times the force and also 10 times the mass, you're going to see that those two are on opposite sides of the equal sign. They can cancel out, and your acceleration is not going to change at all. So the gravity, in this case, mg, is going to be your force. Your weight is equal to gravity times the mass, and so the gravity doesn't change at all. So if you have a small force divided by a small mass and you have acceleration, and then you have 10 times the force divided by 10 times the mass and have the same acceleration, then the ratio of the force to the mass is going to be the same. So a freely falling object will undergo the same acceleration no matter how much the object weighs. Now, to understand this, you really have to go back to the first law. The first law said the more massive an object has, the more inertia it has, and the less likely the less propensity it has to change its motion. If it's stopped, it wants to stay stopped. And so if it's dropped out of a window, that big mass wants to stay in the same place it is. It doesn't want to start moving. Now, it eventually will start moving, but it's sluggy, and a smaller mass is easier to get started moving from rest. Well, the gravity is countered out by the inertia. So the ratio of force to mass is the same in both cases, gravity. So why is it? Because the bigger mass has more inertia, it's less likely to move. Since it's less likely to move, it takes more gravity to make it move. So when those two cancels out, you end up with gravity being the same anywhere on the surface of the earth. So quantitatively, if I were to say 10 newtons, okay, 10 newtons of force on 1 kilogram of stone, you're going to get gravity of 10 meters per second squared. That's 9.8, rounded up. If you were to have 10 times that and you have 100 newtons but a 10 kilogram weight, when it cancels, you're still going to get the same gravity. So something 10 times bigger is not going to move faster because it has 10 times more inertia, and so that 10 times more inertia is going to be divided into its force of weight, and the gravity will end up being the same. So why do all freely falling objects fall with the same acceleration? Do you know the answer? Because the ratio of force over mass is the same. No matter what you weigh, your force divided by your mass has the same acceleration, and that's 9.8 meters per second squared.